Okay, so Mars colonization, right? We've all seen those like futuristic visions, sleek habitats and rovers zipping around.
Right.
It's so exciting. But here's a question that I feel like often gets lost in all the hype. What about families? Like, could humans safely have babies on Mars? I mean, you sent over some research on space radiation and pregnancy, and it's pretty eye-opening.
Oh, it is. It really does highlight just how hostile space is,
Right.
compared to our cozy Earth. We're incredibly lucky to have, the magnetosphere and atmosphere that act like a shield against most radiation.
Right.
But on a trip to Mars, you are just bombarded by something called galactic cosmic rays, GCR.
Yeah, these GCRs. They sound like something out of a sci-fi movie.
They do.
Can you break those down for us a little bit?
Yeah, so imagine tiny supercharged bullets zipping through space at nearly the speed of light.
Wow.
That's essentially what GCRs are.
Okay.
High-energy particles from outside of our solar system. Okay.
And here's the kicker. They can easily penetrate spacecraft and human bodies.
Oh, wow. So it's not just the sun's radiation we have to worry about then? Right. It's this radiation from deep space, stuff we don't even really fully understand.
Right.
It's kind of unsettling.
It is, especially when you consider just how much stronger this radiation is compared to what we experience here on Earth.
Right.
The Curiosity rover, on its way to Mars, was hit with about 1.8 millisieverts of radiation every single day.
Every day?
Every single day.
Wow.
To put that into perspective, the average person on Earth is exposed to only 2.4 millisieverts in an entire year.
Oh, wow. So that's like getting almost a year's worth of Earth's radiation every single day on a Mars mission.
Right.
That's a huge difference.
It is a huge difference.
Makes you wonder what that would do to a developing fetus.
Exactly. Think about it this way. Even a 4-month stay on the International Space Station, which is much closer to Earth, exposes astronauts to 100 millisieverts of radiation.
That's 48 times the average annual dose on Earth.
Wow.
And we haven't even touched upon what it's like on Mars itself.
Right. And that's what makes this research on pregnancy and space travel so important.
Yes.
We're talking about potentially starting families on another planet, but we don't even know if it's safe.
We have guidelines for radiation exposure on Earth.
Yeah.
And in the U.S., the Nuclear Regulatory Commission suggests that pregnant women shouldn't receive more than 5 millisieverts during their entire pregnancy.
Right. 5 millisieverts for 9 months.
Yes.
But the data suggests that a 6-month Mars mission could expose a pregnant crew member to 90 to 324 millisieverts.
That's right.
That's already 18 to 65 times the recommended limit.
Exactly.
From just the trip.
Yeah.
And that's not even being on Mars itself.
And once you're on Mars itself, the daily exposure would exceed that safe limit in just over a week.
Oh my gosh.
So we're talking about constant high levels of radiation exposure.
Yeah.
Both during the journey and on the Martian surface.
Right. So constant exposure.
Yeah.
That's really concerning.
Yeah.
Especially when you consider the ethical dilemma.
Right.
We can't exactly send pregnant women to Mars just to see what happens.
Absolutely not. It would be completely unethical.
Yeah.
To experiment on pregnant women. And they're developing babies like that.
So scientists have to rely on data from space missions.
Right.
Like what happened to the Curiosity rover.
Yeah.
And create these computer models to try and understand what the risks might be.
That's right. And even with this limited data, it's clear that space radiation, especially these mysterious GCRs, poses significant dangers to a developing fetus.
Okay, so we know space radiation is bad.
Yeah.
But what does that actually mean?
Yeah.
Like for a developing baby?
We know that radiation can damage cells and DNA.
Right.
In developing fetus, that damage can lead to a whole range of problems, birth defects, developmental delays, even an increased risk of childhood cancer. And that's just what we know from studying radiation here on Earth.
Right.
GCRs are different and could have even more serious unknown effects.
Yeah. It's like playing a dangerous game of chance with the developing human life.
Exactly. And we haven't even talked about the long-term consequences.
Right.
What happens to these children as they grow up on Mars?
Right.
Will they be more susceptible to health problems later in life?
Yeah.
These are all questions that we simply don't have the answers to yet.
It makes you realize just how much we take for granted here on Earth.
Absolutely. Our atmosphere and magnetic field are truly remarkable shields.
Right. They are.
Yeah.
But the million-dollar question is, can we replicate that protection for a Mars mission?
Yeah.
What about shielding? Could that solve the problem?
That's what scientists are working on, but it's a huge challenge.
Yeah.
Remember those supercharged bullets we talked about earlier?
Yeah.
Well, GCRs are incredibly difficult to stop.
Right.
They can penetrate even thick layers of metal.
So even our best spacecraft are basically like paper against these GCRs.
It's true.
Yikes. That doesn't sound very reassuring for a pregnant woman on a 6-month trip to Mars.
It's not. And it's why we're a long way from pregnancy being safe on Mars.
Yeah.
Our current technology just isn't up to the task of providing adequate protection from this type of radiation.
It's a sobering thought. It seems like we're so close to reaching Mars.
Yeah.
But in reality, we're still so far from making it a truly habitable place for humans.
Right.
Especially families.
Especially families. It is a sobering thought. And it brings up some pretty big questions about the ethics of Mars colonization.
Yeah.
Is it even responsible to consider sending families to Mars?
Right.
Knowing these dangers?
It's a tough one. I mean, space exploration is all about pushing boundaries.
Right.
Expanding our horizons, but not at the cost of human lives.
Exactly.
Especially those of innocent children.
And it's not just about the radiation risk during pregnancy either.
Right.
We also need to think about what life would be like for children growing up on Mars.
Yeah, I imagine it would be pretty different from life on Earth.
Oh, absolutely.
I mean, for starters, the gravity on Mars is only about 38%
of
what we're used to here.
That's right. And we know that gravity plays a huge role in human development.
Mm-hmm.
Bones and muscles grow stronger when they have to work against gravity.
Right.
So what happens when you take away more than half of that force?
Yeah.
We simply don't know how Martian gravity would affect a child's physical development.
Right. Would they be taller and thinner because there's less gravity pulling them down?
Mm-hmm.
Or would their bones be weaker, more prone to fractures?
Possibly.
It's fascinating and a little bit scary to think about.
It is. And it's not just physical development we need to consider either. There's also the psychological impact of growing up in such an alien environment.
Right.
Imagine being a child on Mars looking up at a pink sky
Right.
and knowing that you're millions of miles from Earth.
Yeah.
The only home humanity has ever known. That's bound to have an impact on your sense of self and your place in the universe.
It's like we're talking about creating a whole new branch of humanity.
Mm-hmm.
One that's shaped by the unique conditions of Mars.
Yeah.
Martian kids might develop completely different ways of thinking and interacting with the world compared to their Earth counterparts.
It's definitely a possibility. And it raises even more questions about what we consider normal or healthy development.
Right.
Our current understanding is based on our experiences here on Earth.
Right.
Will those same standards apply on Mars?
So on top of figuring out how to protect pregnant women and developing fetuses from radiation, we also need to think about how to create an environment on Mars that supports the physical and psychological well-being of children.
Exactly. And that includes things like creating artificial gravity environments, providing adequate nutrition and healthcare, and establishing social structures that promote a sense of community and belonging. It's a monumental task, but one that we need to start thinking about now.
It makes you wonder if maybe we're getting ahead of ourselves with all this talk about Mars colonization.
Possibly.
Maybe we need to take a step back and really consider what it would take to make Mars a truly sustainable place for humans. Not just for a few brave explorers, but for generations to come.
I think that's a really important point. We tend to get caught up in the excitement of the technological challenges, but we can't forget about the human side of space exploration. We need to be thoughtful and responsible about how we approach this endeavor.
So if we know that pregnancy is this risky on Mars with current technology, what are our options? Do we just give up on the dream of Martian families?
Well, giving up is not really in the spirit of space exploration, is it?
Right.
And thankfully, there are some brilliant minds working on potential solutions.
Okay.
One area of research is focused on developing advanced shielding materials that can effectively block GCRs.
So basically creating a super shield that can deflect those tiny supercharged bullets we talked about earlier.
Exactly.
Is that even possible with our current understanding of physics?
It's certainly a huge challenge, but scientists are making progress.
Okay.
They're experimenting with different materials like hydrogen-rich plastics and even magnetic fields to see what works best.
I remember reading about a concept called magnetic shielding. Where you basically create an artificial magnetic field around a spacecraft or habitat. To deflect radiation. Is that a viable option?
It's definitely an intriguing idea, but it would require a lot of energy to generate and maintain such a field.
Yeah.
And even then, it's not clear if it would be 100% effective against GCRs.
Well, what about shortening the travel time to Mars?
Yeah.
I mean, the less time you're exposed to radiation, the lower the risk.
Absolutely. And that's another area of active research.
Okay.
Scientists are working on developing faster propulsion systems, like nuclear fusion engines. Okay.
That could significantly reduce the travel time to Mars.
Yeah.
Perhaps down to a few months or even weeks.
Wow. That would be a game changer.
It would, though.
Not just for protecting against radiation,
yeah,
but also for the psychological well-being of the crew.
Right.
Imagine being cooped up in a spacecraft for 6 months versus just a few weeks.
It would make a huge difference.
It would. And then there are even more radical ideas being tossed around.
Oh, yeah.
Like creating artificial gravity environments within spacecraft.
That's right.
Now that sounds like something straight out of science fiction.
It does.
How would that even work?
One concept involves rotating the spacecraft to create centrifugal force, which would mimic the effects of gravity.
Oh, okay.
It's still very much in the theoretical stage,
yeah,
but it's a fascinating possibility.
It is. Imagine being able to walk around and exercise in a simulated Earth gravity environment during the journey to Mars.
Yeah.
That would not only help with bone and muscle health,
but also make the whole experience a lot more comfortable.
And potentially safer from a radiation perspective.
Right.
If we can reduce the overall exposure time, we might be able to make pregnancy and child development on Mars a more realistic possibility.
So it sounds like there's hope for Martian families after all.
There is.
But it's going to require a lot of innovation and collaboration between different scientific disciplines.
It will. And it's going to require a willingness to think outside the box.
Yeah.
And challenge our assumptions about what's possible.
Right.
But I believe that if we're serious about making Mars a new home for humanity, we need to find ways to make it safe for families to thrive there.
And that brings us to the big question.
Yeah.
What does it actually mean to colonize Mars?
Right.
Is it simply about planting a flag and establishing a human presence, or is it about something more?
That's a question that we as a species need to answer.
Right.
And it's a question that has ethical, philosophical, and even spiritual dimensions. What are our responsibilities to future generations of Martians?
Right.
What kind of world do we want to create for them?
These are big questions.
They are.
And they're questions that we need to start grappling with now before we get too far down the road of Mars colonization.
I agree.
We need to have a clear vision of what we're trying to achieve and what values will guide us along the way.
And it's not just up to scientists and engineers to answer these questions.
Right.
It's a conversation that needs to involve everyone. Politicians, ethicists, philosophers, artists, and everyday citizens.
Right.
The future of humanity on Mars is something we need to decide together.
Yeah, it really is a conversation that needs to involve all of us. Because here's the thing, we're talking about the possibility of a whole new human civilization on another planet.
A civilization that would face challenges we can barely even imagine right now.
Like, what would it even mean to raise kids on Mars? Imagine a playground where the gravity is so weak, you could practically leap tall buildings in a single bound.
Well, maybe not buildings, but they could definitely jump much higher and farther than any kid on Earth. And think about the sports they'd invent. Low-gravity basketball, Martian rules soccer.
It's mind-blowing, but all jokes aside, we're talking about fundamental changes to human development, things we take for granted here on Earth.
Things like bone density, muscle growth, even the development of the inner ear, which is crucial for balance. We simply don't know how Martian gravity would affect these things long-term.
And what about the psychological impact? Growing up in an enclosed habitat, knowing you can't just step outside and breathe fresh air, that's got to have some effect, right?
Absolutely. We've seen how isolation and confinement can affect astronauts on long-duration missions, and those are highly trained adults. Imagine what it would be like for a child growing up in that environment.
It makes you wonder what kind of society would emerge on Mars. Would they still have the same values as us? The same connection to Earth?
It's fascinating to think about. Maybe they develop a whole new set of values, a Martian philosophy, if you will. They'd be pioneers in the truest sense of the word, shaping a new world and a new way of life.
And that brings us back to you, dear listener. We've explored the dream of Martian families, uncovered the harsh realities of space radiation, and even glimpsed at potential solutions in the uncharted territory of raising kids on Mars. What are your thoughts on all of this?
Does this research change how you view Mars colonization? Does it make the challenge seem more daunting or perhaps even more inspiring?
Because here's the takeaway. We're still a long way from pregnancy being safe on Mars, but that doesn't mean it's impossible.
It just means we need to be smart, innovative, and maybe even a little bit daring to make it happen.
Maybe one day we'll look back at this moment as the starting point of a truly remarkable journey. The journey of humanity becoming a multiplanetary species.
A journey that begins with a single, crucial question. What will it take to make Mars a home, not just for explorers, but for families, for generations to come?
And as we wrap up this deep dive, that's the challenge we leave you with. Keep exploring, keep questioning, and keep imagining what's possible. Until next time on The Deep Dive.